All right, thank you. Okay, thanks for presenting me. I'm Young Seok-an. I'm going to talk about today about leveraging technology and innovation for climate resilience, which also includes safe energy transition. So we have a lot of materials to cover. So since I've been already presented, I'm going to skip this part and go right into the content. And then we're going to start with the perspective in the climate change. I really wanted to be in person there physically, but I have other obligations here in Korea, so I'll be doing remotely. But nonetheless, hopefully this content will be useful for you to address different challenges that you'll be facing today and tomorrow. So let's start with climate change in perspective. So climate change is a very complex situation. It's a very complex crisis. It touches every aspect of human civilization, from economic to social to politics. We have to move people around depending on the climate situation. It also affects the economy, whether we have to provide financial assistance to other countries. It also affects the gender equality, all these areas that ICH is advocating very strongly because everything is tied together. But the problem is that, as UN Secretary Antonio Guterres has mentioned, there's no clear and effective global strategy to deal with climate change. So there's two responses to climate change today: the mitigation and adaptation. The mitigation is about reduced action to reduce the greenhouse gases, including trying different mechanisms, improving the efficiency of the processes to reduce the emission that we emit from the different processes, enhancing sinks, as in removing carbon out of the atmosphere. The other one is adaptation. The other one is action to help people to adjust to the current and future effects of climate change. Those countries and areas that has already been affected by harsh climate, then we have to improve the infrastructure, restore the wetlands and so on, so that people can adapt and then adjust to the new normal. So what are the elements, what are the key elements for a safe energy transition and decarbonization? So we have to start with people, the actors, those people that will actually do something about it and create new innovation, new processes, apply new mechanism. The other one is the policies, whether the policies come from the global global policies, could be national policies, could even be policies within the industry or also within the organization itself. And of course, the focus of this topic, the focus of this presentation, the technologies. We actually need a lot of help from the technology to make all these changes happen. And finally, the most important element is action. We need to put all these things together and move into the action. So I'm not going to go over all these items. These are the 10 guidelines for secure energy transition as presented by IEA 2022. And I'm not going to go over each of the item, but just pick a couple. The first one, if you see, scale up clean energy technologies with scale back of fossil fuel. That means that we need to introduce new technologies for new renewable technologies. That means the technology is involved here. The second one, tackle the demand side of and prioritize energy efficiency. That also requires technology to handle a lot of information, a lot of data about demand and of course about the supply. And also understanding the poor communities and everything here requires a lot of information about a lot of data processing. So let's jump into the actual technologies. Now I'm going to go list of technologies one by one, and I understand that the audience here are executives and high-level management and also policymakers. So I'm going to keep it somewhat high level, but nonetheless try to touch a little deep in those areas that is needed. So why technology is crucial for tackling climate change? First of all, as I mentioned before, climate change is highly complex. It's one of those problems, challenges that has been unprecedented, and it's a profound with a profound complexity in which if you want to tackle it, if you want to resolve it, we have to understand deeply all the relevant factors. And these factors includes a huge, immense amount of data that needs to be collected, analyzed, and processed. The data will come from environmental data, economic and industry data, social data, and also political data. So what technology exists today? What technology is available so you can use? We can talk about the clean energy, renewable energy generation, energy storage, the hydrogen one, energy efficiency, smart grids, enhancing lightning, HVACs, forestry and land use, the reforestation and afforestation, sustainable forest management, the materials, how we can use materials that are lower energy consumption, also how we increase the ratio of waste to energy. Food tech, the technology, agrotechnology, how we can use alternative proteins, which we know that proteins from cows are high emitting sources. Also, how we can make more efficient the farm, how we produce food. Also, the circular economy, how we can reduce the waste that we produce on different activities that we do either in business or overall city operation. And of course, we have the carbon capture and carbon management, the direct air capture, or also the carbon sequestration from the direct sources. But if you see all of these technologies that I've just mentioned, they produce or they require also not just by themselves, but we need what we call information technology, the IT. The IT includes geographic information system, GIS, the AI, machine learning, blockchains, big data, Internet of Things. And this technology will actually optimize, enhance, accelerate, and amplify the other technology that I just mentioned before. So by each of these technologies, we require a seminar, a whole conference by itself. What I'm going to do is I'm going to focus and concentrate on the IT area. So this is a technology stack, or how they stack together. So as you can see, the IT technology stays on the bottom. Those are the ones that provide processing, provide data management, provides data collection, and ultimately provide insight of how we're going to use, how we're going to optimize, how we can improve the overall operationalization of these other technologies. So from here, you can see that we can start tackling the resource optimization. We can do data modeling and simulation to understand how the real world happens, but in virtually without the high cost of making it real. You have the energy efficiency and also carbon management to understand where the carbon intensity in all these operations. And then, of course, on top of that, each of the technologies I just mentioned. Now let's start with the first technology, the Internet of Things. What is it? So Internet of Things is physical objects embedded with sensor. We associate sensors and we put in place strategically in different area of the real world so that we can capture the information and convert it into the digital world. So if you see the diagram here below, the physical world, which contains or which have analog data, will have sensors. For example, the traffic information, for example, the temperature, the moisture, and so on. All that information will be captured, digitized, and stored digitally. And ultimately, we will get insight out of that. So the purpose is to automate the collection of data instead of having some mods going daily basis and capture that information. We'll capture that information frequently, like continuously, and increase the frequency of and accuracy of data. But it also comes with consideration. As you can see, as you can imagine, it will generate a large volume of data while it's collecting this, which will require additional maintenance of all these devices as well. So how it can help in this fighting against the climate change and improve with the energy safety. So let's just pick a couple of use cases. In buildings, for example, we can capture information about the temperature and optimize the HVAC, which is heating and ventilation and air conditioning. in turn, that will improve the energy usage. Whether the human are present or not, whether we continue using or keeping the air conditioner on, and the brightness lightning, whether we want to dim it further because we no longer need, because you can actually use the natural light of the building. For the factory, it will be something similar. The energy consumption of the processes, we can optimize them, the production level with the energy, we can capture the energy intensity. And also for farms, we can capture the soil moisture, so we can improve the irrigation, the temperature, and also amount of light. All that will eventually have all this data, real data at hand, so we can actually optimize and improve the production or the utilization of all the precious resources. Let's move on to the next technology, big data. Probably you have heard of this one before. It's been quite popular a couple of years ago, but still it's being used underlying. So one of those underlying technologies. And big data is about high volume, high velocity, and high variety of information. You have data that comes from all multiple sources, and they're being stored somewhere, in this case, somewhere that is cost effective. And the way you process that is innovative. So you will capture all the information and ultimately will help you to get insights, make better decisions, and all this process is being automated. So if you see the diagram below, you see that you can capture information of the climate, all this information that comes from the IoT, the technology that I just mentioned before. In addition to that, you will link with information about the business transactions. And also from there, you can generate data, simulation data for the future. So that all that will generate relational data. We call that structured data, those data that have structure. It could also generate unstructured data, such as images, sounds, and so on. And also graph data, which are connection of data, those data that may have semantical relation in between those. And what we do with all this information, we store petabytes of information and we make sense out of it. So the purpose is to analyze like a big data, full data, instead of sampling them. So now we have more accurate information. We have full insight of the entire universe of data. But this technology also comes with consideration, as you can see. Big data, you need big spaces, you need a lot of computation power. It will also consume a lot of information. But not only that, if you have a lot of information, you have to make sure that like personal information are not there, or they're very secure. So you don't have any issues about privacy and also security. Moving on to the next, we have so the big data, how you can use. As I mentioned before, all this information coming from the IoT, you can start computing them, processing them. But also, if you see smart grids, will create a lot of information, and the information will be to optimize supply and demand data. We'll also need a better adaptation of variability of renewable resources or renewable source of energy, such as the wind farms or solar. They're not consistent, so you have to be able to predict those. So in order to predict, you need a lot of information. That's where big data plays a big role. Also, fault detection. These smart grids or all this, anything that are physical, they're not fault tolerant. They cannot stay up 100% all the time. And those fault detection also needs to be adjusted or needs to be understood such a way that we will need to predict them and be able to handle them in advance without to reduce the downtime. So not only in the smart grid, but also in climate analysis, you can easily imagine yourself seeing that a lot of information comes from climate, and with big data, you can handle that information. Also, another use case will be transport optimization. With all this traffic that comes daily, and you can analyze per minute or per hour basis, and that is a lot of information that you have to process. But then with big data, now you can do things like route optimization, adaptive traffic signal control, and so on. Let's move to the next technology, blockchain. You might have heard of this. Probably if you heard about Bitcoin, then you might be a little bit familiar about blockchain. But nonetheless, I'm going to mention this and how it can affect in terms of energy and climate. So this is a database system that maintains data in a way such that multiple entities, and when we say multiple entities, are those people in a member that are member of a conglomerate or member of a group that shares some information. That shared information must be trusted, and this mechanism of blockchain allows to that high level of trust. The way that this is achieved is that this member, they all are connected in a peer-to-peer way, so there's not centralized information. So first of all, because it's not centralized, uh, there's no single point of failure. So in terms of security, of reliability, that's a big plus. And the information itself, whenever there's a new information is added, uh, that is added only after all these peer goes through a consensus. So when all these peers says yes, that data is indeed authentic and correct, then they add that into the block, and that block is keep adding, and it has a hash. A hash is a key saying, "Hey, I am who I claim to be, and also I'm the next block to the prior one." So if you want to change, or if some hacker tries to change any of the information here, it actually needs to change all the information in the block and needs to change all the information of all the nodes in a distributed system. So that's a lot of a technical aspect, but nonetheless, suffice to you to understand that if you have a blockchain, then you can trust the information there that will be good, reliable, and authentic. So again, the proper purpose of blockchain is to increase trust in the shared data and automate the reliability of data storage and exchange. In addition to that, I haven't mentioned here, but you can also add additional features such as digital apps, we call dApps, and you can trigger, it's called smart contracts. Whenever some event happen, you can trigger that information automatically, and that trigger is also trusted by all the peers. Another consideration to this is also costs of infrastructure. And for those who are familiar with Bitcoin, the mechanism of consensus can also be quite time energy consuming. So that's another consideration to take into the picture. So how blockchain can help? As I mentioned previously, one of the key benefit of using blockchain is increased trust, which means that now that we trust the system, now that we trust the information, you can easily trade certificates. So that could be a green energy certificate, like such as renewable energy certificates or RECs. Could also be trading of energy. Let's say that you have a microgrid, and now the user can trade themselves the energy, and they trust that what they have traded are correct. And also in supply, a sustainable value chain. Let's say that you're a company, and you want to make sure that whatever you're sourcing your raw materials from multiple companies at multiple tiers, and you're saying that you're becoming more sustainable and net zero, and you don't want to have any issue with greenwashing, as in media or other people telling that you're not providing the correct information. With blockchain, now you have end-to-end traceability of products, of all the data that you have procured, which means that you have greater transparency. You can trust that the information that you're disclosing are correct. And not only that, now that you have end-to-end traceability, you can know where to reduce the emission. You have better insight of the opportunity for emission. let's move on to the next one, the GIS, Geographic Information System. So this is actually a combination of technologies that can also include sensors and big data. It's a computer system for capturing, storing, checking, and displaying data related to position of Earth's surface. And information can include uh, such as streets, buildings, vegetation, carbon emission, and so on. The purpose is to provide better insights on geographical data or data that you can map to geographical area. And this information can support global or policies, local policies that you want to uh, differ area by area. Now, the consideration is that in order to set up the whole system, it will take you quite a time. Like it's not simple. You have to go layer by layer, and you require a different sensor. You require different equipment to make this happen. Now, how the GIS information, the GIS is being used today. It's being used as a climate change modeling. It's also being used by detecting emission leaks, especially, for example, the methane sat uses satellites, and also GHG sat uses satellites to identify leakage in different areas of the globe, even those areas that are far from where people are. Also, it can be used to cross-check calculated emission. As you know, we can either calculate the emission depending on the different emission factors. And in order to make more certain that the calculation are correct or close to the real world, then we might want to check with this information. And also we can verify how the land use is being changed in different area. And the land use actually affects the climate because depending on how the land is being used, it actually a green area can become either carbon sink or carbon emission area. And lastly, but not least, the GIS can also be used to locate the correct or appropriate area for installing renewable energy sources such as wind farms and solar panels. With this GIS information, you want to find which area which is not used for other purposes and you're not affecting minimally the biodiversity, but also has all the different factors in place such as goods, it has wind, so you can put wind farms and all that information, all in order to have your installation get most as in return of investment, you better want to have all this evidence in place. So now let's move on to our last technology, AI and machine learning. Machine learning is part of AI. And there's a lot of definition out there, but I'm going to use this one, technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy. So basically it's to enhance human in order to get better insights of problem solving. And I doubt that it will replace human altogether, but rather it's going to expand the capacity of human because we have memory limitation. But for AI, now the limitation is all the data that we have in place. So within the AI, there's a lot of branches that you can consider, and I'm going to focus on those that are quite relevant and is one of those technologies, cutting edge technologies today. So we have what we call machine learning, that those properties, those mechanisms that gives computers the ability to learn without explicitly being programmed. So you give data input and it will learn from that, as in it will adjust the parameters and will produce an output, the desired output. And within the machine learning, we have neural network. Neural network is a structure which is inspired by human brain, the neurons and synapses. So when you trigger some inputs, it causes an output. So we have what we call activation function in each of the neuron, and then we combine the neurons together to produce an output. And this has been successfully used in various domains such as pattern recognition. And within that, we have the deep learning where we start putting all not just one single layers of neural network, but we have multiple layers of those, and that will enhance and provide higher capability of learning. And then finally, we have the generative AI, the Gen AI, those ChatGPT that probably most all of you have used or you've been using recently. That's the generative AI, and that's based on a lot of deep learning, and there's a lot of factors. There's new factors called like attention, and what we do is that it generates. It's basically statistical neuron, but it generates what would come next. But for us, all this data that's the what we call big model, large language model, it produces an outcome that is very relevant to our context or very relevant to the question that we have given to the system or the computer. So if you see, the purpose is there's a lot of purpose. There's a lot of use cases that you can apply this. But the important thing here is that also it comes with drawbacks or consideration. First of all, it's energy intensive. I'll mention this again. There's a issue of hallucination and bias. Depending on what data you train the computer, you train the machine learning, it will actually can favor or come with a wrong data. And also may increase inequality as if you don't provide this to the general user, then only few will have access to this. Now, AI machine learning, what can it do? In fundamentally, it does this task, the pattern recognition. Like if you give one thing, let's for example, an image of an apple, it will tell, hey, this is an apple. But if you generalize that, or if you apply to a different domain, you can say, if given this pattern of energy usage, what would be this pattern? Whether this is a pattern of a TV or a pattern of a microwave or the pattern of HVAC. So with that kind of information, there's a lot of things you can just do and optimize. The other one is prediction. Given a set of information, it's mostly we call it time series information, and will generate what will come in the next future cycle, whether it's 1 month later or 1 year later. Can do model improvement as you keep providing information, as you keep providing input to the system. It will continue refining the model and train itself to become better and more effective. And then there's also the natural language understanding. You talk to the computer, it will talk you back. And when you do that, it actually has some processes of understanding the natural language. And also there's a speech, text, and text to speech. And finally, the content generation, which is the Gen AI that I just mentioned before. So all these capabilities or this the foundational feature of AI will usually get combined to do all these other things that we hear in the news saying AI is doing this and AI is doing that. AI is moving robots. So all this, the combination of all of this. So right now, how is it helping? This is a list that I found in some of the sources that you can see, and probably you will get this deck afterwards, but let's just go a couple. For example, it's being used already for mapping the deforestation with AI. Just giving a picture from probably from satellites, we could tell whether it's in which phase of the deforestation it is, and so that we can put policies around it. It's helping community face climate risk in Africa. If there is an area in Africa, so this is Africa, but probably in any other part of the world, if it's affected by harsh climate events, then they can help give financial aid to those areas immediately rather than too late. Also using to recycle more waste, as in streamline the waste to recycle process, so we make it more efficient and more proficient. The clean up the ocean, predict climate disaster, so we can prevent or we can help people have get less affected. reforesting hills in Brazil, and many more. So as you can see, the use cases and usage of AI and machine learning is so diverse, and you can probably be creative and apply this AI into your respective domain. So this is a concrete example as a case study, a Google Smart Data Center. And what Google has done is that, as I mentioned before, all this technology require is consumes a lot of electricity, and a lot of electricity means that we are emitting a lot of carbon. And what they have built is what they call smart data center. They're compute, they're scheduling their compute to a specific time frame. So it's done when there's lower carbon emission. So if you see here, if it's in the noon because there's a lot there are more renewable energy sources provided at that time, then the data center will schedule tasks so we'll use more CPU at that time. It also will predict the reliance of carbon intensive energy. So you will adjust depending on the different factors. So I mentioned a couple of technologies. I mentioned the main technologies out there that you can use and mix and match and combine them. But again, they come with risks, and you have to be well aware of this risk. And let's go one by one. One is high energy consumption. As I mentioned, CPU is not for free. It consumes a lot of energy. And just to give you a perspective, when you ask a question in ChatGPT, it will emit about 4 grams or 5 grams of CO2. That doesn't look like much, but if you see that they're actually handling 10 millions of requests per day, that's a lot. That's pretty much like 40 tons of CO2 a day. That's more about the comparison. That'll be like 4,000 cars driven for about an hour. So you have to make sure that you're using those resources effectively and efficiently. The other one is privacy and security. The privacy is about the personal information. If you get hacked, so you have any data breaches, then you will probably in a lot of trouble. It's a high risk handling private information. And with big data, you might need to have some guards to protect against possible risk of breaches of data. And security, if you remember, there were a big issue about Microsoft Windows updates that actually triggered a massive issue and got the whole system down in multiple places, including 911, hotels, airports. And that's because they wanted to do an update on security module. And if you actually have a security attack in either government or hospital or even like energy generator, that could significantly disrupt the operation, not just locally, but the entire country. So those are the things that you probably be aware. But then you also have to understand the AI's possible weak points, which is hallucination and bias. Hallucination is when you ask something to ChatGPT and it answers with a response and it answers such a way that it looks true, but in reality it's not correct. As in, you have to actually do a fact check. So, and bias is when it returns an information that is favors a minority or favors only a subgroup of people or subsection, then that become a big problem. Not only that will affect the operational aspects, as in reducing the being on suboptimal results, but also it could cause ethical issues. The five is rebound effect. All this technology will actually can possibly induce people to buy more, purchase more, use more which will eventually increase the emission, increase the use of consumption of energy, and increase the emission of CO2. And of course, we have the ethical issue. I also mentioned about the hallucination bias. You can easily see that that could cause very important ethical issue. But we also have unequal access to technology may increase social gap, right? If only a few group of people have that privilege of accessing the technology, they will leaving out the rest of the people. Now, having said that, let's take a quick scenario. We don't have too much, so I'm gonna go very quick. So this context, Philippines, the climate change is exacerbating the tropical cyclones and heat waves, impacting energy supplies. Probably, I'm just picking one of the news out there, Philippines, but that's happening not just in Philippines, but many places, and especially those tropical countries. They're going through these issues. And we just look at the energy being used in Philippines, we see that fossil fuel is more than 60%. And there's a lot of imports in energy, which means that there's a good opportunity to improve in those areas. Also, the electricity is mostly relying on fossil fuel, and the electricity in transportation is used only by 0.1%. And if you see the trend is going upwards, all this data will lead us to see that with a lot of with proper data management, proper insight out of the data, we can get a good optimization. 3 minutes. So last is an exercise for you to see which kind of technology, what kind of technology we can apply in these areas which have these challenges. Say, for example, smart grids. We have the challenge of optimal power flow. We have the challenge of demand forecasting. So what kind of technology can be applied here? Actually, I want it to be this interactive, but nonetheless, because of the interest of time, I can just tell you. So we can use AI, machine learning. We can use IoT to obtain all the information, the real-time information, and adapt, adjust in real time. For the renewable energy integration, like where are we gonna install this information? How are we gonna handle the intermittency and the variability? Again, also, we can use GIS information. We can use the machine learning to predict and understand the variability and where we optimize against using the fossil fuels. The energy marketplace optimization, the model of complexity of uncertainty, real-time optimization again, machine learning, and AI. This decentralized energy and energy trading, we can use the blockchain so we can trade peer-to-peer and optimize and make it more efficient with less overhead. Electrification of transport, the sensor would be a good source of technology. Buildings and energy, city energy and efficiency, and all this related to dealing with energy capacities and reliability. Also, predicting how the energy flow will be, we can use AI. And finally, carbon tracking and compliance. For the tracking, we can use blockchain and compliance and understanding where we are having more emission. We can use machine learning, big data to understand and get insights. And here, I think I'm quite on time. I finished this presentation. Hopefully, it will be a right level for you or for all the audiences out there. And ultimately, we want to ensure that the legacy, the planet that we leave behind, is meaningful and lasting. And hopefully, we have to use all the tools out there to make this possible. And of course, as I'm going to repeat this again, the most important thing is action. We need action to make this change happen. Okay, this is the presentation, and see if I have time for any question. I'm going to stop here, and also I'm going to stop